Is it the top one? Ah, that one. Has anybody heard of this guy? Did anybody look at the agenda and Google who this guy was? Nobody? Nobody? All right, so he was, you can tell by the picture, this is a guy who lived a long time ago in the 1950s, and he was credited with basically revolutionizing Japanese manufacturing. So after World War II, the Japanese were interested in becoming a world-class manufacturer, and if you're about my age, you remember in the 70s, Sony, Honda started becoming brands that people associated with high quality. And so his beliefs were that if you improved quality, you would actually reduce cost. And I think in software, oftentimes we think if we test more, it's going to cost more. And I don't think that's necessarily the case. The upfront cost might be higher, but over time, your life cycle cost is actually going to decrease by being better testers. And then he also thought if you improved quality and lowered the cost, then you'd build a very happy customer base, and then you'd have loyal customers. And I can tell you, at least from the American perspective, people were like, I want a Toyota, I don't want a Ford. I want Sony, I don't want, if there even was a American electronics manufacturer. I don't even remember one. So anyway, so what did he think? He thought that what people would previously do would be have independent processes for design, manufacture, and test. And then they'd inspect the finished products to see which ones passed their QA, and then they'd ship those and they'd rework the other ones. So you might have a brake rotor and you have 10 lathes that are producing them, and you get a big pile of them, and then you measure them all, and some of them are in spec and some are not. You melt down the ones that aren't, and you fix them. So what he thought is that if you integrated the processes, and then at each step in the process you took measurements, you would build quality in, and then you wouldn't have this waste at the end. And so, for example, if you measured the rotor that comes out of a lathe right at that point, and maybe you can say, okay, the machine needs to be calibrated once a day, and that's an example of changing your process to have a better result. So how does this apply to software? So this is how we've been building software, and you can say this is a week's worth of work, or you can say this is a year's worth of work. People often say Agile is kind of the answer, but Agile oftentimes is just a mini waterfall, right? So you're still going through a sequence. You can't write code until you have a definition of what it is. You can't integrate it until the code's done, and you can't really test until you have something complete to test. So how does this apply to what Deming thought? So we have independent processes very much. So a lot of our projects still have a test group. They have the people who write requirements. They have the people who write code. They're the geniuses, right? So I'm a developer. The smartest people are the code writers, right? And so we have to keep them away from testing. Well, I'm going to say today that's completely a terrible approach. So we have independent processes. We look at our finished product. So after you have a sprint or after you have 3 years of development, you give it to the QA people, and they're somehow supposed to install quality at the end, quality assurance. And I think we've all had developers say to us, if you manage a group, that it's done, it's totally done, we're just waiting for QA to test it, to ship it. And of course, when you come out of this point, out of the coding, it's usually half done, maybe not even half done. And so the final thing is defective products are reworked. And one of my points in this presentation is the length of time between the code and the test directly impacts the amount of effort it takes to rework and fix the bugs. So what's the cost of the pre-Deming workflow that I contend we're in for software? So independent processes mean that the different stakeholders work independent from each other. So it's the job of the designers to build the requirements. It's the job of the coders to read those often English language requirements and turn them into code, and it's the job of the testers, the QA people, to take the requirements, understand what they think they mean, apply them to the code, and tell you, the developer, that nothing works. So everybody has a different view of what they are building when we operate this way. And then the finished products are inspected to defects. For defects, that means that testing is performed periodically. Even if the period is 1 week, Like I talked to some of our customers and they're saying our goal is to get down to 1 week. So that still means you're taking, if you have a good sized team, 30 people, you're taking the work product of 20 or 30 people, putting it all into a build and then trying to test it. It's very unlikely you're going to have a good outcome from that. So you get slow feedback loop on bugs. I still write code every day. If you say to me a minute after I finish writing something, here's a bug, here's a test that's broken, it's pretty easy for me to fix that. I'm like, oh yeah, I forgot about that case. If you come back to me a week, a month later, my first reaction is, no way did my change affect that test. It's got to be somebody else's fault. Existing features get broken, and then features get stuck in QA. So defective products getting reworked, lots of bug fixing happens late in the cycle, which means what I just said, context switching by the developers, and new features get released much more slowly than managers would like. So how can we apply Deming to software development? Integrated tests, processes. That means a test process has to be part of everyone's responsibility. It's not one group's obligation to write all the tests. Well-defined processes and goals that are shared. And that's a big thing too. I think we get a lot of animosity between teams in software development. So, it's like the QA people don't really understand what I developed, what it's supposed to do. Well, that means the requirements aren't clear if you can't both understand what the requirements are supposed to be. Then continuous testing. And by continuous, I mean every developer on your team should be able to submit any change, however big or small, that they think is complete to a test system that produces some quick output for them, telling them what things got broken. Bug prevention, the root cause. I think this doesn't get done enough with software development. Find out why things really are broken. I mean, we all have the really ugly modules in our products that we're afraid to touch, or we know every time we have to touch them, they break things. You have to look at refactoring that stuff, find out what it does now and come up with good test cases for it to formalize what it does now, and then maybe refactor it. So we'll look at these 3 topics now: integrated test, continuous test, and bug prevention. So how to build in quality with integrated processes. So there are 3 things for this, I think. Test each component before integration, and I'll go into this in the next slide. Build tests at the API level and the requirements level, and then ensure tests are complete. So unit testing gets a bad rap a lot of times because people choose their units to be smaller than they need to. So when I say unit testing, I'm thinking about testing at an API that's a significant part of your application. It might be 1 file, if it's a message processor, or it could be a collection of 5 or 6 files, or 10 files, or 100 files. The idea is to be able to build a test that's functionally interesting. So if you have a function that adds 2 numbers together, yeah, people are going to say, why am I unit testing this thing? I pass in 2 numbers, I get the result, it's okay. It's not proving anything. It's not helping the correctness of the application. So define your components logically. Expose tests to all stakeholders. I think this is a massive problem with most of our development organizations, is that not everyone in the organization can run every test. It's either they don't have access to the test, they don't have the know-how, they don't have the hardware that's required, they don't know the preconditions. So everyone should be able to run every test that your organization builds on every change. Then refactor tests over time. Get in the habit. This is the hardest thing to do. And all these things I'm talking about, we have in my development group. These are things we're struggling with too. That's why I know they're valid. So it's really hard to make yourself throw away a test. This test hasn't failed in 10 years. We're not really sure why we have it. But if we throw it away, maybe something will get broken. Might as well just leave it. And so what does that mean? That means the length of time to run your test gets longer and longer. And then we have these. We have a lot of tests that break all the time. And then somebody says, well, go ask Ray. I think that breaks every night. It's not a real bug. Well, why are we doing that? If 30 people on the project are going to ask Ray every day if this is a real problem or not, it's probably not that efficient. And then we have tests that never fail. Well, why are we running those tests? They've never broken. So that either means that we're not testing the part of the application that we're actually changing, or it means the test is kind of a nominal case that is never going to be broken. So how to build tests for APIs and requirements. Where do you find more bugs? I think this is another reason that component or unit testing gets a bad rap, is people say we find lots of bugs during system testing, the QA people when the whole system's integrated, but we find very few bugs during unit testing. Well, there are a few reasons for that. One is developers, if they run a unit test and find a problem, they're just going to fix it. They're not going to create a bug, put it through the system, go through source code can change. They're just going to fix it. But you should have unit tests, component tests that formalize the behavior that's expected at each API that's significant in your application. This is the other problem with unit testing, and I think the first presenter today mentioned about coverage not being very useful, and I would agree with him. I would agree that coverage isn't very useful unless you use it for the right thing. So code coverage is useful as a gauge of how complete your testing is. By itself, it means nothing. If I write test cases by looking at the implementation, forcing every true and false to be true or false, and then feeling good about the fact that I've tested this application, it means nothing. If I instead look at the API, and I think of how can I call this API versus how should I call it, then that's going to be a much more interesting test. And we see customers all the time where you'll say, you know, we have the ability to auto-generate test cases with VectorCast, and obviously we can force null pointer derefs in almost any function because people don't routinely protect themselves against null pointer derefs. They say, oh, this is handled at a higher level or something like that. But you don't know. Maybe in your application where you're using this module, you're ensuring the fact that it doesn't get called with a null pointer, but somebody else picks up this module. This stuff is hidden deep within the new application, and suddenly they have a null pointer deref. So that's just an example of asking yourself, how can this be called versus how should I call it? And then requirements traceability. That, again, get away from, tests to the API. Think about how someone could ever call this thing. Think of the right way to call it, and then think of what the requirements are, even if they're just in a wiki, a list of things that it's supposed to do, a checkbox list. Think of how the software is supposed to perform. And then this gets back to the coverage point. I think there are probably a lot of you who are under 26262 now, so we've had a lot of new customers for our product that are in the automotive industry, and so they're new to the requirements of requirements-based testing and code coverage analysis. And I think the questions that we got early on from new adopters of the ISO standard is, well, what's the quickest way to get code coverage? And so with that, I would agree with the first presenter saying, thinking of it that way is not the right way to think of it, because you're looking at coverage as a goal. Coverage shouldn't be a goal, it should be a measurement of how successful your testing is and how complete your testing is. Hello? Have I malfunctioned here? That's it. Is there a stop on this, or? Any ideas? Anyone from? Oh, there we go. The battery's out, or? All right. So the next topic is continuous testing. So the best way to make testing continuous is to make it easy to build tests. So with that, we're thinking, Thomas mentioned up front, Vector being a provider of test solutions regardless of the level of testing you're interested in. And so that talks about a single test platform over time. You have a new one? A new test platform over time that'll allow people, regardless of the flavor of testing, you're doing to build tests. So I said a big problem is people getting into boxes. So people do unit testing, and people do integration testing, and people do system testing, and not being able to run each flavor, have anybody run each flavor of test. And so this talks to that, making it easier. And make test execution fast. What I hear from my whole career, what I've heard from people is, I changed one line of code Why do I have to run 3 hours, put in 3n units of time of test cases? It makes no sense, but I think we've all had experience where one line of code made the entire application not work anymore. So that's kind of a fallacy. And it's also a fallacy that the amount of testing should be proportional to the size of the code change. If you change something very basic, maybe your message handler, then you probably want to run all of your test cases. So shorten the feedback loop so we don't have the context switching. And then make testing automated. I think the two best things you can do is to make testing automated and scalable. So there are lots of excuses people have why it can't be automated, but how about changing your design? I'm sure when Deming went to the manufacturers in the 1950s, they said, we can't stop the line to be able to test the size of some component, or we can't check the voltage on something during the manufacturing process. It's impossible. The important thing to them would be to get to the end, to get the manufactured product, but that's not any good if the final product has flaws in it. Test collaboration. Make tests shareable. I've mentioned this 2 or 3 times. I think it's a very important thing. For our particular product, we have between 12 and 14,000 tests, and every developer can run those tests on every branch that they create for a new feature or a bug. And so nothing gets integrated into our mainline branch until all, whatever it is now, 13,000 of those test cases pass. So that means that our QA team isn't figuring out why existing test cases fail. When they get the branch, all test cases that we already have, not to say there aren't bugs in the new stuff, but all test cases that we currently own pass. So they're not going back and saying, Tim, this is you, it's not me. Joe, it's you. Tim said it was you. Back in a circle of people blaming each other. And then remove infrastructure limitations. Most of our customers are embedded. I'm sure most of you are building embedded software. So the most frequent excuse I hear for not scaling testing or not having it automated is lack of hardware. So I think with the virtualization technologies we have today, it's really an unfortunate excuse to say we can't test more, we can't scale our testing because we don't have enough hardware, or we don't have any hardware, and we only have one. QA's using it right now, so I can't run any test cases. There are solutions to these problems. It might take some effort on your part. All of these things will take some effort. And then tests must be small and easy to run, and results must be easy to understand. Just yes, no, is everything good? Then dig down to a fail test. And most importantly, from the standpoint of a developer, is give me something I can debug. Give me a fail test and access to a debuggable image, and chances are I'm going to be pretty happy fixing that problem. So next thing, how to make testing faster. So we have bunches of customers who say their testing takes 3 or 4 days, so it's not that unusual. And we came up with this idea of mapping the code coverage back to the test cases and then using that as an oracle for deciding which test cases need to run for a particular source change. Now, you'd never release your application with only running this subset, but it makes the interim testing for a particular developer much faster, and it'll make that guy with the one-line change probably much more prone to using a test. So change-based testing is basically identifying which, they're yellow or orange, I don't know, the little boxes within your application that are actually touched by a test from a previous execution. And then, again, shorten the feedback. You notice this is a recurring theme for me because, I just know the context switching by developers makes it takes a longer time to fix tests. Can you guys flip it from back there? There we go. So testing automated. In addition to making testing scalable, also making testing automated will pay big dividends. So I hear this a lot from customers too. I was screwing around with the thing. Sorry about that. don't hit this button. All right, here we are. Always blaming the hardware. All right, where was I? Automatable testing. Remove infrastructure limitations. I talked about this in the intro to this section. Virtualized test environments and labor. I often feel like people, at least at management level, don't really understand what their most limiting and expensive cost is in software development. It's the developer and the testers and the QA and the designer. It's their time. It's not really whether you buy a $20,000 server that can run all of your test cases in an hour. That's a small investment for a small group to have automation and parallelization. And push button, it has to be easy. The preconditions can't be that you grep through some document to find where the test name is and find out what you're supposed to do to set it up and go find 3 patch cables and an Ethernet cable and do I have the right switch or hub or whatever. Whoops. All right, so bug prevention. Again, we're going back to Deming, right? So we're trying to improve our process, we're trying to test continuously, and then we're trying to prevent bugs, not just fix them after they're introduced. So what are some quality metrics? You can pick your own, so we're not the holders of the master list of the best quality metrics. Every project should decide for themselves. Cyclomatic complexity basically is the number of unique paths through a function. People will complain about that. Don't take a vote on your project. Take a couple people who have been doing your application for a while and try to come up with metrics that they think would really make a difference in quality. Interface complexity, I see that, I see a lot of people where they'll pass in a structure to a function, even though they're using one field from it. Over time, somebody else uses that. They said, oh, this field is already available to me, so I'll use it. It's not preset by the caller, things like that. Analyze the data. We have plenty of data. I've had customers say to me, we have all these point solution tools. They produce a ton of data, but they don't really allow me to know what I should do to improve things. So I think with scoring, the new dashboard that's part of the Vector group now, you're going to have good opportunity when you see that tool in use of being able to see actionable intelligence. Collect a bunch of metrics and look at them with different screens to see what story they're telling you. And use data to improve the process. So especially with non-safety critical industries, with business systems or something, people would often say to me, what level of coverage should I strive for? What level would be good? I mean, would 80%? Why is 80% better than 70%? Obviously, you'd like to deploy an application where all parts of it have been tested before the user gets into that particular branch of the code. It's not feasible to take something that's at 20% coverage and stop everything and write test cases to get you to 100% before you do anything else. That's unreasonable. I wouldn't suggest that. But what is reasonable is posting the current coverage percentage and then over time, every month, posting the new coverage percentage and having everybody feel good that you've made progress, not that you're at 20% forever and it can't be improved. So, like I said, I don't care what metrics you choose. Every application might have slightly different metrics that they'd like to use. Bug counts, that's a really poor indicator probably because there are a lot of probably non-critical things that are wrong with your application, all of our applications. Interface complexity, I mentioned. Comment density, I love it when developers that on our team say, I write code that's self-documenting. The variable names I choose are really good so I don't need comments. It's just laziness. Frequency of source code changes, that's another metric. If you connect to your CM tool, if you're using something like Git, you can get a history for the files in your application to see how quickly they're changing. And there's a good chance that the ones that change the most frequently are introducing new bugs, or they're fragile in the first place. And then testing completeness, again, code coverage. What have we achieved? If you don't measure coverage, how do you know how complete your testing is? If you only measure coverage and have that as your goal, then your application's probably not getting any better. So analyze the data, publish some data. It doesn't cost much to put an LED screen up on the wall of your office. Come up with certain metrics. I've heard of companies publishing like the new defects for each section of the application, the new customer reported defects or something like that. You need to have goals. You need to have achievable goals. It can't be like our goal is 100% coverage when you're at 20 or 30% today. So you can't measure progress or feel good about what you're doing. Another thing, I think, is getting buy-in from your team. Don't just put a new metric or a new gate on people's activity without telling them the rationale behind it and what you're trying to accomplish. And trends are the key. It doesn't matter if you're at 20% coverage, 40%, or 80% coverage. If you're getting better over time, it's a good thing. And so the final thing, I think, is quality gates. So if you don't have any gates on developer activity, you'll get really ugly code over time. There's no doubt. Because humans, by the natural tendency is to do the minimum. It's just, people will do what they're asked to do or what they're forced to do. And most of the modern CM tools make it very easy to implement a gate before check-in. So particular things, if you're using Coverity as a static analysis tool, why not implement it automatically on your check-in process so that no new Coverity errors are introduced? At least the person making the check-in will go back and look at why they introduced a potential null pointer or a memory leak or something like that. So some gates, you can pick your own. You don't have to do all of these. Cyclomatic complexity in the avionics world, people always thought less than 10 was a good thing. It doesn't have to be 10. 12 isn't that much worse than 10. But 100 is probably pretty bad if you see something that's nested down 8 levels. With too many gates, nothing gets done, right? And with unexplained gates, your developers will all quit. So, if you say you have to do these 50 things, they'll say company B across the street won't make me do anything. So build documented workflows for each activity. As I said, most of the modern CM tools make it really easy to insert hooks into the commit process. So you say a branch can't go to QA, that's what we do. A branch is not ready for QA until all existing test cases pass, and we have a dashboard that shows the status of every branch in development, and it gets run, every branch gets run automatically every time there's a push to it on a dedicated virtualized test server. And then the quality gates must be automated. It can't be, I need you to type these 12 commands in order to commit something or in order to pass something to QA. Make it easy for people, and people will be happy to conform. So the final thoughts are build in quality, measure quality so you know where you are, and then improve the process. And that's it. How did I do on time?
Thank you very much.
Tape the button.
It's a really hard thing here to think with. Are there questions from the audience? No. But after lunch, it's usually...
Everybody's sleeping?
I try to be awake.
I see a lot of open eyes, so it's not...
Yeah, some people have the possibility to open their eyes even if they're sleeping.
Oh, that's a good thing. Yeah.
But nevertheless, I have a question. You present a lot of ideas, a lot of nice ideas. What's your opinion? What's the most important tip or the most important thing you want to tell a team?
Automate your tests. If you have manually run tests, they're never going to be run, or they're going to be run once a month or something like that. Mm-hmm. So to me, somehow find your way to the point where you can automate tests. They're GUI tests. There's some amount of pushing buttons you have to do. There are tools for that, depending on your platform. But if that's the case, make the GUI layer as thin as possible so you can test the callbacks right underneath it.
Thank you. What about the teams? Do you think separate teams are perfect, or would you integrate developer team and test team into one team?
I think it has to be one team. It has to be like we're trying to accomplish something. We're all trying to accomplish the same thing. The ping pong of it's your fault, it's our fault, doesn't work. And our developers build all the basic low-level tests for their stuff, and they get reviewed by QA. And then QA's responsibility is beyond a new feature to see that the whole thing plays together, because developers won't think of what's in some other part of the tool, what's the side effect. So I think integrate it.
Thank you very much.
Thanks.
There's one question.
Whoops.
Oh, so
now we're starting up.
Hello.
Maybe one more question. On which test level do you think does it make sense, and how much effort will it be? So low-level tests, system tests, or do you think it's the results are for every test level?
I think so. There are two schools of thought. Like, as a product, our initial customers were avionics, and the tradition in 1996-7 was to do coverage 100% at the unit level, and that takes a lot of work. And you know you're going to get some amount of code coverage from your higher level tests. There's no doubt about that. So I think it's a good approach to mix the types of tests. I think, you know, there's a place for system testing. Obviously, you have to make sure the whole thing works, but there's also a place for things that you know are building blocks of your application to make sure they work and are very robust at the API level.
Thank you.
Hello.
One additional question.
Thank you for an excellent presentation. A lot of the recommendations you make rely on the fact that there is effective automation, for example, for generating test cases, running test cases, analyzing test cases, automatically finding out that there is a failure, reporting information about that failure to enable debugging. But the fact of the matter is that the technology to do that, as it is today, is very limited. I mean, just test case generation, if you look at what is being done, for example. It's extremely limited, not scalable, it doesn't work in all conditions. So don't you think that to fully implement your recommendations, we still have a long way in terms of building the underlying technology for test automation, for example?
Yeah, it's a fair question. When you say automated, though, do you mean somehow reading the requirements automatically and knowing the test vectors? Like, would that be an example? That doesn't exist, so.
Yes, that's, if you do requirements-driven testing, yes, that would be the way to go.
So I think we're a long way from having
yes,
that. Yeah.
Because if we are in a situation where the requirements are changing, the software is changing, you know, it's basically what you described. Having people go through thousands of test cases, identify which ones are obsolete, which ones need to be rerun, which ones don't need to be rerun, how should the oracle or the test verdict change? You cannot have the type of continuous testing you are talking about.
Yeah, so we have for free, we look at the source code changes to tell you what tests to run, but we also have a connection to the requirements. Both Canoe, the traditional vector informatic tool, and VectorCast both have requirements traceability. And part of that requirements traceability allows you to get a cross-reference of the test cases to the requirements. Sure, there's review that has to happen.
Yes, but the devil is in the details. For example, you know that a test case might be affected by a change, but it might be, you know, how would I say, affected by the change in the sense that the oracle or the test verdict now should be different, or it could be that the test inputs don't make any sense anymore, or it could be that it needs to be rerun but it doesn't need to be modified. And by just looking at what code is covered by what test case, that is not that easy to automatically answer those questions.
Yeah, so my view has always been, like all the things you just said, my view has always been, let's use the smart engineers to do that, but let's not use them to do the other stuff you said, which is like finding out what tests fail, finding out what the subset of tests that are affected by a requirement. All of that is easily automatable. We still need the intelligence of the engineer to make the final determination. And our tools are all about allowing you to automate the drudgery stuff. So why, when the code changes, does the engineer need to rebuild his API test? Our tool can do that automatically. And then he can use his judgment, okay, I've got 80% coverage now to build the new tests. It's a valid point. I think things can always get better, right? So I've been doing this 35 years, and they're a lot better. The first system I worked on, took us 6 months for the thing not to crash. It was like 100 people. We integrated it all. It had all been unit tested. It didn't work for 6 months. So I think things are better in that sense. We've got more collaboration tools. They could always be better.
No, I completely agree, but I guess what I was trying to get at is that maybe one reason why people do not follow those recommendations as much as we would like to is because the technology is not up to speed yet.
Yeah, see, I kind of disagree. I think there's room for improvement, but there might still be things that are manual, like the graphical testing for an avionics application, a glass cockpit application. You might actually have to press some buttons, turn some dials for that. But the large portion can be, I'm convinced that it can be automated, and I think people a lot of times say, if I can't achieve 100%, or maybe I should have had that in the slides, if I can't achieve 100% or 80%, no sense in trying to make it better. I think that's a big stumbling block to improvement. If people saying, it's always been terrible, can't be any better, what's the use? So.
Work. Thank you very much for the fruitful discussion.
Thanks.